Okay, so what we discussed in the previous class, what we covered? We covered the Ohm's law. Yes,
Yes, sir.
I derived Ohm's law in the terms of the resistivity. As I remember, I write down the expression of the Ohm's law. Just a minute. The expression was R is equal to rho L upon A. Yes, where rho is the resistivity and rho is equal to M N E square tau. Yes, please ask.
No, sir. No, sir.
Yeah. So we derive this relation. What is rho? Rho is the resistivity or the specific resistance. Specific resistance means spatial resistance. What is the speciality? Suppose the length of the wire is A, the cross-section area is also A, then resistance of wire is rho. So resistivity is the specific resistance or the spatial resistance when the length of the wire and the area of the wire is same and both are 1. Okay, so it is this. But we can write down resistivity in terms of the mass, electron charge, and the relaxation time, which is this. And I already discussed that it is inversely proportional to the relaxation time. When relaxation time increases, resistivity decreases. When relaxation time decreases, resistivity increases. Suppose you increase the temperature of the metal. When you increase the temperature of the metal, then due to the high energy of the electron, the collisions becomes fast. Okay, so each and every electron is colliding with another electron fastly. So relaxation time reduce. When relaxation time tau reduce, then resistivity increases. So in this way, resistivity is proportional to the temperature. If temperature increases, resistivity is also increases, and so resistance. Is it fine?
Yes, sir.
Yes, sir.
Yeah. So let me tell you more details how this resistivity is linked with the another parameters of the wire or the resistance of the wire. See, rho is m upon ne squared tau, and r is equal to rho L by A, and for unit length of wire, R is equal to rho. If L is equal to 1, A is equal to 1, fine. But from here, you know that from the Ohm's law, R is equal to V upon I. Yes. So it is this. Yes. Yes or no?
Yes, sir.
Yes, sir.
We can interchange L and I. So V upon L will be rho I upon A. And rho value is this. M Ne squared tau I upon A. What is V upon L? V upon L is the electric field, E. So E is this. This M Ne squared tau or rho I upon A. But what is I upon A? I hope you know very well. What is I upon A?
Oh, sir, I upon is wait, what's it? Q. It's a
Current
wait.
density. Current
Oh,
density. Yeah.
yes, sir. Yes, sir.
So E is equal to rho J. See, The use of current density is here because electric field is a vector quantity, and so current density should also be a vector quantity. Now it's fine. So that's why we denote current density as a vector quantity, because we know that later on we express current density or the electric field in terms of each other, or the current density is 1 by rho E. Okay, 1 by rho is nothing but reciprocal of resistivity. 1 by rho is known as the conductivity. So J is sigma E. Okay. This is this. Is it fine?
Yes, sir.
Sigma is the conductivity or the specific conductance. Just like rho is the resistivity, similarly sigma is the conductivity or specific conductance. Okay. So it's very easy, it's not very difficult to derive this. Okay, let me show you again.
Why like the three equal?
Not a 3. Where is the 3?
Sir, like the three lines.
Oh,
Like
these are equivalent. See, one is the equal and one is the equivalent. This means it's the equivalent and this is the equal. Generally, when you are writing equation and you are equating left hand and right term, then you use the symbol this, equal. And when you are defining something, then you generally write down the conductivity, the 3 lines. Okay, equivalent. So sigma is equivalent to conductivity and is equal to the specific conductance. Okay.
Yes, sir.
It doesn't matter. You can use the equal sign. Okay, it doesn't matter. Okay, it's up to you. Is it fine? Yeah.
So I have
yes,
a
sir.
question.
Yes.
Let's say we use the 3 lines like the sign for like the equivalent, like in the exam. So will it be wrong?
In the equation.
Yes, sir.
Yeah, in principle it should be wrong, but generally we don't. Teachers don't consider it is wrong. Okay.
Okay, sir.
It was a very, very minute mistake. Even elders, even the experienced person sometimes do such kind of the mistakes. Okay.
Okay,
So
sir.
it's fine. Yes. Okay. So see how we derive. It's a very simple. R was rho L by A. Okay. We were interested in some relation of the E. So I'm expressing very fastly. See, to memorize it, I'm just showing how you can memorize. R is V upon I, rho by L by A. So, or directly you can write down, because E is V upon L. V is equal to EL. Just write down V is equal to EL directly here. Cancel. So E is rho I upon A. The same thing. Now I upon A is a J. So it's just one or two lines. These lines you should memorize always, because in the exam you will confuse whether it is E is equal to rho J or whether it is J is equal to rho E. You will confuse definitely. I'm sure. You
Yes,
will
sir.
forget.
Like this, sir.
Yes. Yes. So always derive. Okay, it takes hardly 1 minute. Okay. Use pencil and derive. Okay. And don't memorize both expressions. Either memorize this expression or either memorize this expression. If you try to memorize both expression, you will confuse definitely. Memorize only one,
One
and
is
when
enough.
someone is asking other, derive it from first expression. Okay.
So one is enough.
Yeah, one is enough. See, first of all, don't memorize. Yeah, means if someone is asking anything, just derive it and give the answer. If you want to memorize, then memorize either this one or the second one.
Oh,
Okay. If you memorize this one, you can easily, even in a fraction of a second, you can derive this. Okay. Or if you memorize this, you can derive this. But if you memorizing both of them, then definitely you can confuse easily. Okay.
yes, sir.
Yeah. See, I am just telling you because I check several thousand copies, and students are not getting marks just due to the silly mistakes they forget during the exam, whether J is equal to sigma E or whether the J is equal to rho E. And many times they are writing and then they cutting, then they writing, then they confuse they cutting. Now many times. Then in the last they are doing something. Sometime it is right, sometime it is wrong. Okay, so it's happened during the exam. Okay, is it fine?
Yes, sir.
Yeah. So finally, it is this. Okay. Current density is equal to the specific conductance into electric field. It means if you increase the electric field, definitely current density will increase. Or if there is a good conductor, means the sigma is high, then also current density will increase. So current density or the current, it depends upon two things: the quality of the conductor and the amount of electric field applied on the conductor. Okay, is it okay, Aditya? Hello?
Yes, sir.
So this expression is famous with the name of the Ohm's law in vector form. So this expression name is the Ohm's law in the vector form. Just like in the usual form, V proportional to I or I proportional to V. In usual Ohm's law, current is proportional to the potential. In the vector form, current density is proportional to the electric field. Okay, so Ohm's law in a vector form states that current density is directly proportional to the applied field or electric field, and the direction of the current density coincides with the electric field. Okay, or more specifically, you can say that it says that current density and electric field ratio is a constant, which is the conductance. Just like it says that V upon I is a constant resistance. Similarly, it is this. This conductance sigma is independent of the electric field producing the current. Is it fine?
Yes, sir.
So even students confuse. Suppose there's a question in the exam, write down Ohm's law in a vector form. 80% student will write down this. Okay, and what did it generally do? They confuse. They do. Understood? They are just trying to put vector sign. They are thinking that Ohm's law means vector form means the put vector sign.
Oh,
Not all the student, but major audience. So it is the Ohm's law in a vector. Okay, is it fine? Hello, should I proceed?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now the combination of resistance. So I will discuss the electrical energy and power later on. Okay. First, let me discuss the combination of resistance. I hope you already familiar combination of resistance from class 10th. The rule is same. In series, suppose there are many resistance in series connected with some battery. So current will flow in all resistance and the amount of current is same. Okay. So, but the voltage is divided in 3 resistance. So in a series, total voltage is divided into 3 parts, V1 plus V2 plus V3. Okay. So V is, suppose it is I into R. R is a total equivalent resistance. Means instead of 3, 1, if there is a 1 single resistance, then equivalent resistance should be capital R. Suppose you want that I am using the same battery and I am using the same amount of current, then what should be the value of the total resistance? So it is capital R. So V is IR, V1 is IR1, V2 is IR2, V3 is IR3. So I is same, you can cancel. R is R1. So the equivalent resistance of the resistance connected in a series is equal to the sum of the individual resistances. Okay. It means whenever you require high resistance in the circuit, okay, or whenever you require low current in the circuit, you should connect all the individual resistances in a series.
See.
Yes.
Yes, sir.
Similarly, in a parallel, combination, suppose there are 3 wires, R1, R2, R3. They are connected with some battery. So the voltage is V. Voltage will remain same because voltage is a function of the point. But the current will divide into 3 parts, I1, I2, I3. So the total current is I1 plus I2 plus I3. And I is what? I is V by R. I1 is V by R. I2 is V by R2. I3 is V by R3. You can cancel V both sides. So it is 1 by R, 1 by R1, 1 by R2 plus 1 by R3. So it is in a parallel combination. The value of the total equivalent resistance in the parallel is actually less than the any one of the resistance, any smallest resistance. So when you want a minimum number of or the smallest value of resistance, then you should connect all the resistance in the parallel, just like in a household circuit. In our household circuit, there are various electric bulbs, fans, heater, refrigerator, and all they are connected in a parallel. Okay.
Yes, sir.
Why? Because the resistance is minimum, and if suppose one of the system is not working, then others will work efficiently. Suppose this is not working, okay, then these two will work. But in a series, if any one of them is not working, then others will also stop. So it is this. Okay. Yes.
Yes, sir.
Yes, sir.
Okay. There's a very interesting thing. It is removed from the syllabus, but in the Viva, I think teacher can ask. So it's not a very long thing, very almost 5-minute exercise. So I'm just explaining. It is known as the color code of registers.
Oh.
But it is, I think it is removed from the syllabus, from the theory.
Oh.
Yeah. But it's a very, very interesting thing. I don't know why they removed color code. Color code is what? See. See, in the circuit, in any register, if you see any electrical circuit, there is a register. In a register, it is easily visible that there are different colorful lines: green, red, black, orange, okay, and so on. Okay, just with the help of the colors of these lines, you can find out what is the amount of resistance of a specific register. Okay. Okay. So first of all, these registers are known as the carbon register. Okay. And the rule is this. To memorizing the rule, then it is B.B. Roy, Great Britain, very good wife. Okay, so see here, so just memorizing it is a B.B. Roy, B.B. Roy, Great Britain, very good wife. It's just memorizing, but B means black. Next B means brown. R means red. O is a orange. Y is a yellow. G is a green. And next B is blue. V is a violet. And next D is a gray. And last W is a white. Okay, and the value of these are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and okay, let me explain how you can find out what is the value. Suppose this is the case. This is your resistance. And someone is saying, okay, tell me the value of the resistance. Okay, or okay, choose some another one. This one is a little bit easy. So I'm using the 3 colors only: the orange, red, and green. And tell me what is the value of the resistor. Okay, what is the resistance? So see, first is orange. choose orange. Orange is this. Put 3. Second is the red. Red is what? 2. Write down 2. Third is the green. Now the third one, green is 5. You should write down in a multiple of 10. 10 to the power 5. Okay. It is this. Understood?
So it's like, so the BBRO, YG, like those are random, yeah?
Yeah. It's just arrange. See, just identify this. Suppose I am asking the resistance of this. So suppose this is the register ABCD. So
Yes.
first is 0. Okay. Second green is 5. Fine.
Yes.
The third is red. Red is 2. Okay. Fine. The fourth one is the orange. Orange is 3. So it is a 10 to the power 3. It is this. 52
Oh.
10 to the power 3. Okay. The last one you should write down in terms of the 10 to the multiple. Okay.
So only 2 numbers will be like we write the whole number.
Yeah. You can
Only
use the
2
3 one.
digits.
Suppose. Say suppose there's another wire and they are these colors. Maybe blue, red, orange. Now, orange, maybe some white. White. I'm writing it's white. Okay. So, what is the value? Blue means first value blue is 6. Red means 2. Aditya, are you here?
Yes, yes, I'm listening.
Okay. The third one, orange. Orange is 3. The fourth one is white. Yeah, it is a huge.
So is it always like necessary to remember the colors, right?
Yes, this you should memorize. So you can memorize in this way. And the BB Roy, Great Britain, very good wife. And it's very simple. First B is a black, brown. Okay. Then R is usually red, O orange, Y yellow, G green. That is okay. Next one is the blue. V is a violet. See, it's very easy. First is
So but the letters, it's like it's too random.
how it's random. See, first a black. Okay, just black and brown are very close. And see,
Oh, yes, it is those.
in any color combinations, you know that after the red, orange will come. After orange, yellow will come. Green will come. You just memorize the blue. Then after blue, violet will come. Okay. Yes, gray and white are random. Yes. So you have to be memorized. No other way.
Yeah. So like the middle letters are all like part of the rainbow.
Yes. Yes.
Okay.
And there's another catch. In the resistance, there are 2 extra colors sometimes. 2 extra colors, 2 extra lines. One is the gold and another is the silver. Sometimes it's there, sometimes it's not there. Okay. What is the meaning? Sometimes there's only gold line, sometimes it's only silver line. Okay, sometimes no color. So gold means 5% error. Silver means 10% error in the resistance. Whatever resistance you are writing, if there's a gold line, means 5% error. If there's silver line, means the 10% error. And no line means 20% error. Okay. It is known as the tolerance. Okay, it is known as the tolerance. So it is this. So it is removed from the syllabus. So in the board exam, they will not ask any question. In the school, during the Viva, Maybe they can ask, maybe they don't ask. So you don't need to memorize. Just look upon it and say that okay, I know, but I don't know exact formula. I don't can say that. It's up to you. Okay.
Yes, sir. Yes.
Yeah, fine. So there's a next. There's a thing is the temperature dependence of the resistance or the resistivity dependence on the temperature. But before this, I want to discuss. Okay, let me discuss few numericals, easy numerical, very easy numerical.
Okay, sir.
In a hydrogen atom, an electron moves in an orbit of radius 5.0 10 to the power 11 meter with a speed okay. Find the equivalent current. It's very easy. Just do it quickly. Think about it. See, current. They're asking current. Current is what? Current is charge upon time. What is charge? Electron charge, you know very well. What is the electron charge? Electron charge value is
1.16 10 pound minus 19.
yeah upon time. What is the time? How you can calculate the time? Radius is there, velocity is there. So time is distance upon speed. 2 pi r upon v. Okay, with the help of this formula, you can calculate time. And if you have time, if you have a charge, you can easily find out the value of the electric current. Okay.
Yes, sir. Yeah.
You can calculate at your home. The final answer is 1.12 milliampere. Milli means 10 to the power minus 3. Okay.
So milliampere.
Yeah, milli means 10 to the power minus 3. Okay. Should I proceed? Or you people are calculating?
Yes, sir. Yes.
Okay, do it. No issue. Should I proceed?
Yes, sir. You can proceed.
Okay. So the next question is a copper wire of cross section area one millimeter square carries a current of 0.21 ampere. Okay. Find the what? Drift velocity. Okay. Of free electrons. If the density of the free electrons in the copper is 8.4 into 10 to the power 28 cubic meter per cubic meter. Keep in mind, if density is written in the terms of cubic centimeter, then please convert it into the cubic meter. So it is correct. It is converted already in the per cubic meter. Now give the answer of the drift velocity.
So we have to convert millimeter to meter.
So yes, you have to convert millimeter into the meter square. Aditya, is it okay?
Yes, sir, I get it.
Okay. So which formula you will use? There are many formulas to calculate drift velocity. So which formula you people will use?
So I'm using the drift velocity formula, like so V average is equal to sorry. So EV tau by ml.
Okay. You are saying you will use this formula? Yes.
Yes, sir.
But neither potential is given, neither relaxation time is given, neither length is given.
So or we could use A into tau.
How? So acceleration is not given. Tau is not given at all.
Oh.
So how you can use this? Instead of
Also,
A and yes, yes.
instead of tau, we can
Think about it little bit more.
Sir, do we
Yes.
sir, do we use the one which is I is equal to V and A?
Yes, yes, yes.
Yes, so because it fits like that, right? Like you can
Yes.
take
You,
V on one side and then just bring all on the other.
yes, you people
Yeah, so
can use this one. Yes, I is there, A is there, so use this formula. Okay.
Oh, okay. Yes, sir.
Yeah. So n is also given. Small n is given. Per cubic meter means the number of electrons. So n is given, I is given, A is given. Just convert area into the meter square. And finally get the answer. Here it is okay. You can use I is equal to any AVD. But in the
Okay.
test
Yes.
paper, I will give you one question in which you will confuse and you will try to use this formula, I is equal to NAVD. But you should not use this formula. In there, you should use A tau formula.
Oh, okay.
And I will give you in the test paper, most probably, after the completion of the chapter. And maybe you can understood very well, or if not, I will explain you how and why we should use particular formula in a particular condition. Now it is clear, very clear from because I and area is given, that's why we are using VD. But in some situation, it can be confusing that either we should use the A tau or either we should use the NAVD.
Oh, okay.
Okay. Should I proceed?
So it's 0.21 divided by so 8.4 into 10 to the power 28 into 1.6 into 10
yes,
to the power minus 9.
final answer will be this. You can verify at home. Okay, let me calculate it. Because I know you people don't have time. I is 0.21, N is 8.4 in 10 to the power 28. Electron charge is 1.6 10 to the power minus 19. Area is 1 millimeter square. Millimeter means 10 to the power minus 3 meter. Okay.
Yes, sir.
Now, just minus 19, 28. So it will be how much? 90 will go on 10 to the power 9 or minus 6. So it is 0.21, 8.4 into 1.6 into 1 upon 28 minus 19 minus 6. So how much it is? 9, it is 10 to the power 3. And this one is so it is 21, 84 into 6 or 16 into 1 upon 10 to the power 3. So 4, 64. So it is this or 100. So 100 upon 64 is something roughly to 1 point something into 10 to the power minus 5. And what I was writing? I was writing the answer was 1.5 10 to the power minus 5. Yes. Okay.
Yes, sir.
See, in answer, this power should be the correct one. The first number and the power. Okay. Okay.
Sir, could you give me 1 minute? I'll be back.
Yeah.
Yes, sir. Yes.
There is another question. The question is the resistance of the wire is RO. What will be its new resistance. If it is stretched to n times its original length. So wire is stretched almost n times to the original length. What is the new resistance?
Oh, sorry. Yes, so it will be so n times.
No. Think about it.
So R is rho L by A.
Okay, oh yeah, that is fine. But see, we are stretching the wire. If you are stretching the wire, area will not remain same.
Okay.
Area will reduce, na? Because you are stretching the wire. Length will increase, but area will decrease.
Oh, yes, sir. Yes.
So if area is decreased, then definitely this will not work. So you should find out how much area is a change. What is the new area? Just like the new length is the n times of the original length. Similarly, calculate the original new area in terms of the original area.
Oh, okay.
Aditya, is it okay?
Yes, sir.
See, if you have any doubt, you can stop me immediately.
Yes, sir.
Any idea?
Yes.
No. See. Okay. Suppose this is the wire, original wire. Area is A, length is L. Now you stretch the wire. New area is A prime. New length is L prime, which is NL. That is okay. So, which quantity will remain same? It is the specific resistance. It will remain same because specific resistance is only depend upon the material. It does not depend upon the area or length.
Oh, yes.
Yeah. And another thing is the volume. Volume of the first wire will equal to the volume of the second wire. Because volume is not changing. Length and area is become changed, but volume remains same. It means A1 upon A prime upon A is L upon L prime. And L prime is NL, so it is a 1 by N. It means new area is old area upon n. So it's very easy now. You find out new area, you have new length, then you can give the answer of the new resistance. New length is NL, new area is A by N. Put it here. So it is N square rho L upon A, which is the old resistance. So new resistance is the N square times of the old resistance. Oh, is it okay?
601.
Oh, yeah, note. It's a very interesting question. It's my favorite question.
Okay.
And a very simple question, very simple.
Yes, sir.
If by chance I check again your the chapter 1 answer script by mistake. I was checking your chapter 2 answer script, but I downloaded the chapter 1 answer script and checking. And soon I realized that I already checked, I think. So I will check your chapter 2 answer script maybe tomorrow, and I will show you and I will send your marks. Okay.
Yes, sir.
The next question is a wire, cylindrical wire, is stretched similar to this question. To increase its length by 10%. Calculate the percentage increase in resistance. Okay, do this. See, you have to find out the new area. New length is already 10% increase. So new length is L plus 10% of the L. Okay. But first you have to find out the new area. Then only you can find out the new resistance. And after that, you can calculate the percentage increase in the resistance. So how you will approach this question? See. Okay. See, the new length is Aditya, are you getting what I'm saying?
Yes, sir, I'm getting.
Okay. So new length is this. 10% means 10 upon 100 of L. It is how much? So L plus 0.1 L. Is it okay, Rihan?
Yes, sir.
It is a new length. So the ratio of L prime upon L is 1.1. Fine. You know that the volume is same. So AL is equal to A prime L prime as usual. So it means A upon A prime is L prime upon L, which is 1.1. So A prime is A upon 1.1. Now the new resistance is rho L prime upon A prime. L prime is 1.1 L. A prime is A upon 1.1. So it is a 1.1 square rho L upon A, which is the old one. Okay. So it
Yes,
is
sir.
this. So it means R prime by R is this. So R prime by R is 1.1 square, which is 1.21. So the percentage is this, which is R prime minus R, which is means 1.21 minus 1 means 0.21 into 100 means 21%.
Wait, so can you show the previous page once? Let me. Yes, sir. So can you explain again, like,
Yeah,
how
yeah.
did we? No, no, no.
See, it is a similar one, the previous. The Y is stretched 10%. Okay. So the
Yes.
10% of L is, we find out the 1.1 L. It means L prime by L is 1.1. Just like in the previous question, the L prime upon L was N. Here is the 1.1. Okay.
Oh, okay.
Now our task is to find out the percentage increment. Okay. But before, let me calculate the new resistance. To calculate new resistance, we need new length, new area. New length is okay, 1.1 L. But what is the new area? New area
Okay.
is the same method as I used the previous problem. A upon A prime is L prime upon L, which is 1.1. So A is just interchange this.
Oh,
Understood?
yes, sir.
Or just compare here. A by similarly. Just put all the values here. So it is a N square R. Yeah, 1.1 square R. Okay. Is it okay till
Yes.
here?
Yes, yes.
Now,
Yes, sir.
now R prime by R is this 1.21. That is okay. But for us, they are asking percentage in R, which is this delta R upon R into 100. Delta R means the change in R, the value of the change in resistance. New resistance minus old resistance upon old resistance into 100. So it is what? R prime by R by R is minus 1. R prime by R is 1.21. Put it this 1. So it is this. Okay.
Oh, yes, sir.
So you need to practice. Okay, I will try to send you some problem. The chapter is little bit lengthy because I have to be discuss the Kirchhoff's law, and there are so many numerical problems on the Kirchhoff's law, specifically Kirchhoff's second law. Okay, and after that I will discuss this Wheatstone bridge and the meter bridge. Okay.
Yes, sir.
Is there any doubt, any question, any query?
No. No, sir.
No. Okay. Aditya, do you have any query?
No, sir, no query. It's clear.
Okay, fine. Good night.
Okay, sir.
Good night, sir.